welcome to all the people on YouTube who are now joining us via live stream. We hope that the live stream is working well. We hope you'll let us know actually how well it's working or what could be better for next time. We're eager to hear how that's working. I'm Naomi Black. I'm a technical program manager on Angular, and I'm here to introduce Miško, who is the father of Angular, who's going to be doing our main presentation today on best practices.
Thank you, Naomi. How's it guys going? Good? All right. So, as I always say, I love questions, but do keep in mind when you do ask questions, because we're live streaming, make sure you grab a mic so that people can, yes, Naomi will offer the mics.
There's only one mic. It's a little bit special. You won't hear it, but the people on YouTube will hear it.
All right. Maybe we're just pretending. I'm just kidding. So let's talk about best practices. What is best practices, and why should you do it? Well, best practices is, things that people kind of figured out over time is a good idea to do, because it helps to maintain the project, and it helps when people come on board to figure out how the project is structured, and also when you go to different projects, to kind of helps you to kind of keep in sync and say, yeah, this is kind of a good idea to do everywhere. And so, what are the kind of things that we have discovered over time are good for Angular? Is kind of the question that we're trying to answer. And while it's hard to have global statements that this is always good and this is always bad, so what I'm going to try to do is going to say these are the kind of options that we think you have, and these are the kind of trade-offs that these options provide, and so only you can kind of make a best decision as to which one you think is best fit for yourself. So the first question that oftentimes you'll want to answer is, how do I structure the application? And so first of all, does it really matter the way you structure the application? Well, to some degree it doesn't. It really, one structure is as good as the other. But as I said, once you structure it in a particular way and other people structure it the same way, it makes it easier to leave one project and join another one. And for people to explain, if you have conventions, configuration over conventions is the big thing that Ruby brought to this world. And so we kind of believe in that as well. So, we created a particular structure, which is called Angular Seed. It's actually a GitHub project that you can go and check out. It's at Angular/Angular Seed, and it basically sets up a directory structure where you have everything that you deploy in the app folder. It has a index HTML, both synchronous and asynchronous. We'll talk about the script loading later. All the resources are in particular directory structure, but more importantly, it has the whole environment for development. So anything outside of the app folder is things that you need for development purposes, but you don't actually deploy. And most important one of those is having tests. So we have example of end-to-end tests, how to write them and set them up. This would be an example of one. And similarly, we have an example of a unit test, and how to set them up and run them, etc. So we provide you with basically everything you need to get a basic Hello World application going and running. So that's Angular Seed, and we recommend that you basically clone the repo and go from there. Now, Angular Seed was actually created way before this other awesome project came along called Yeoman. And Yeoman is kind of the replacement of something that we kind of recommend people doing, because Angular Seed is a starting point. Once you clone it and start working with it, it mutates, and if we come up with a better practice, you can't take benefit of it, because you can't go back in time and check out a different version of Angular Seed. But Yeoman is kind of a dynamic directory structure. So with Yeoman, what you can do is it first of all sets up your directory structure similar to Angular Seed, but it also provides dynamic commands that allow you to add controllers, remove controllers, add directives, and all in a kind of an automated fashion. They also allow you to set up your testing environment, run your tests, manage your dependencies, and I'm sure a bunch of other things that I'm forgetting in here as well. So we actually recommend Yeoman. Few months ago, we actually had a tech talk on, a meetup. We actually discussed Yeoman. Brian did a wonderful job, and so that's available on the Angular channel. You should check it out and find out more information about Yeoman and how to do it. So let's take a break for a second and have a little Zen moment over here. Oops. So Angular, one of the unique things about Angular is that we have dependency injection, and it's the thing that actually assembles the application and makes so that you don't actually have a main method. And this is a very unique point of view, because what it allows you to do is allows you to assemble the application in a different way for the purposes for the testing, for example. Or if you discover that there's a service that we've implemented and it's not quite to your liking, you can very easily with dependency injection replace it with some other service that does something that you like better. And so dependency injection is kind of the core of everything, and you should definitely embrace it and use it, because it's what Angular is all about. So let's talk about how we load scripts. So you have a couple of choices in loading the scripts. You can use the script tag, and you can use something like asynchronous module definitions like require.js. And they both have their advantages and disadvantages. And so let's talk about first a simple way of using script tags. So again, if you check out built with, if you check out our seed, the standard indexed HTML has script tags at the bottom of the page. The reason you want to put the script tags on the bottom is because script tag loading is blocking. And so if you have the script tags in head, that actually prevents the browser from rendering the page until all the script tags are loaded. By putting it on the end, you can show something useful to the user while he's waiting for the rest of the pages to come in. Now with dynamic applications or Ajax applications like Angular, the benefit of putting the script tags at the end is a little diminished, because usually Angular is the thing that will render your page. And so you can't really display too much useful stuff while it's being loaded, but there's some couple of things you can do. And I'm going to show you an example of that. Is actually our built with Angularjs.org page. And if I refresh, pay attention to this 44 neat things built with Angular. If I refresh, notice it renders a question mark first, and then it renders the actual number. And so what's happening is we load the template, which just contains the question mark because we don't know what the number is. And at the bottom, we load the script tag, which kind of bootstraps the whole process. Going back to this, if you're using, this is called synchronous loading, the way you bootstrap an application is something called ng-app. And this basically tells the Angular framework that, once it discovers ng-app, it can go ahead and start executing the application. Now, it's called synchronous for a reason, because the browser blocks. And so sometimes it might be beneficial to load things asynchronously. And so for that purpose, we have something like require.js is a popular way of loading things asynchronously. And there's a lot of confusion people have between the require.js module system and also Angular module system. And the only thing I have to say is that even though the names are very similar, it's actually a different concept. Angular's modules deal with configuration of the injector, and the configuration of the injector defines how things are built at runtime, and the building of things is something that happens throughout the lifetime of the application. Whereas require.js deals with how script tags are loaded into the browser, and that only happens at the beginning, and it happens only once. So it's actually different goals that the two seek, and they're actually very complementary. But there's an important difference, which is that if you have an async index.html, the biggest difference is that you can no longer have ng-app. So if you go scroll to the top, notice there's no longer ng-app present inside of your HTML. And the reason for that is that the way Angular bootstraps itself is it waits for the DOM content ready. In other words, the browser says, okay, I'm finished loading your HTML file. And then it looks for ng-app directive to see if there's anything that needs to be bootstrapped. And if you're loading asynchronously, then the asynchronous can load the Angular after the content ready, or more importantly, it can load the Angular library before it loaded the application library, application code base. And so the Angular might start up before the application is actually being loaded. And so there is no good way for Angular to know when it's ready to actually run stuff. And for that purpose, if you load it manually with something like require or any other script loader, you have to basically provide a manual bootstrap, which is essentially equivalent to saying ng-app equals my app. This thing says, pretend that there's an ng-app at the root of the document, and the application to load is the my application. Does that make sense? All right. Son of Angular. It's kind of relaxing. I can go fast at times, and so this is good to have little breaks. So oftentimes when you work with third-party applications, you lose things that are asynchronous. For example, you talk to a backend server that returns data, and then when you update the model, you're going to be surprised to discover that your UI doesn't update. And that's because you have changed the model outside of the lifetime of Angular, and Angular doesn't know that the model has changed, and so it needs to be notified of it. And a good way to think about it is that, just like a browser flip-flops between the render state and the JavaScript execution state, you can subdivide the JavaScript execution state into just regular JavaScript and then Angular JavaScript. And the way you enter the Angular world is through the scope.apply method, which basically says that go perform any operation to change the model that you might have to do. And then when you're done performing the operation, perform its normal life cycle so that we can re-render and update the UI. So the apply method is kind of your way out of most third-party integrations. So when you're loading your first page, index.html, you can have a flash of unstyled content. That is, the double curlies that you placed in your page, they can show up. And the reason for that is because the browser renders the index.html before Angular has a chance to look for them and then replace them with proper behavior. And so obviously that's an undesirable behavior. And so there's a couple of ways you can counteract it. One is something called ngcloak. This is by far the simplest. And what it basically you're doing is you're putting a style that says ngcloak attribute display none. And then you're placing an ngcloak attribute on the body. And what that basically does is it tells the browser that please do not render the body. Angular has a directive called ngcloak, and what it does is basically removes itself from there. And so the browser loads index.html. There's unstyled content in there, but because of the style and ngcloak, the browser is told don't render anything. Once Angular boots, you see the actual application without any kind of flash. Now this is good. It kind of fixes the problem of the unstyled content, but the drawback of this is that there's a delay before you actually render anything. You now have all the benefits of putting the script tags at the bottom of asynchronous loading it are kind of negated by not actually rendering anything to the user. So a slightly better approach is to do what the built with Angularjs has done. And here's an example again where I was showing you the number of things that are built with Angular. As you can see, if I refresh, it says it renders an unknown thing, and then it puts the actual number. And the way that actually works is if we go to view source. So here's the string, as you can see, neat things. And we have literally placed the question mark inline in there. And instead of using double curly, we're using attribute ngbind. And obviously, attributes are not rendered by the browser. And so this allows us to, this is essentially equivalent of putting projects.length, putting this expression into double curly inside of here. But the advantage is that, the advantage here is that we don't have a flash of unstyled content. So what we're recommending is that for index.html, you use ngbind instead of double curlies. Now, do you have to use it in your whole application? No, just in index.html, because once you get into your individual views or directives or anything that you dynamically load into the browser, that gets fed through the compiler before it gets rendered, and so there's no issue anymore. This is purely just for the first page load. And since the index.html typically is just the Chrome of the application, that tends not to have a lot of double curlies or a lot of bindings placed in there, so it should be pretty straightforward to do. So the next thing you probably want to do is you want to minify and do a compilation. So do you need to do minification is the first question. And our experience is that about 80% of what your application typically does if you build something, the conventional methods like jQuery, about 80% of what you write is actually just DOM manipulation. And so by using something like Angular, you already are ahead on the size of your application because you can remove that 80% case of DOM manipulation. So that's already a first benefit. Not necessarily saying the benefits of minification of your code is become less needed. But still, there are reasons to minify code. And if you do minify the code, you have to know a couple of things about Angular. First of all, the views use reflection in order to access the model. So if you put double curly, and inside a double curly you put an expression like username, then it needs to have a property called username on an object somewhere inside of the model. And if a minifier executes and minifier then minifies, and the way it minifies is it renames long names for short names, and it most likely will change something like username to something short like A, it will no longer work because the reflection no longer works. So for this reason, when you use minifiers, you have to disable property renaming of the code base. Now you still can gain a lot of benefit from variable and parameter and renaming, and also removing the white space and all the other stuff that minifiers do. So the added benefit of property renaming is actually, depending on the style of the code base you write, might or might not be that big. But most of the benefits, the lion's share of the benefits is in renaming the variables and parameters of functions. And that's called basic optimization in a JS compiler. And by turning that on, you can get a lot of the benefits, but those parameters are actually used for dependency injection. So let's have a look. So suppose you have a mic controller. You can say, I need scope and a greeter being some service that's defined somewhere else. And what minifier essentially does is it renames those two parameters. And so when Angular tries to figure out what to inject, it will go and read the actual renamed name, and obviously the service name is not renamed and it will fail. So to help Angular out, you can create a property called $inject, and you can place that property on your injectable functions, and that basically says, ignore the normal names and instead use the strings that are in here, and obviously the minifier doesn't rename these. But what it means is that if you know you're going to have to do minification at some point in the future, you need to place these annotations, these parameter annotations properly inside of your code base so you can take advantage of it. Now, typically inside of your tests, there's no need to place these because there's no need to minify tests. This is just for the production code. But placing this annotation in this style could be cumbersome because, for example, let's say you are defining what a greeter is and you say, well, there's some module factory greeter and it takes another service called window. Clearly, the window is going to get renamed to something else, like in the case over here using the minification. And then the issue becomes that you can't register the function inline like you have seen it over here. Instead, you have to assign it to a local variable so that you can assign a property $inject on it, which is the window, and then take that variable in here. So you're getting a bit of a explosion of code, and we don't like that in Angular. And so we actually have an inline style, which is declared over here, where you wrap the function essentially in an array, and then you put the parameter names in here. And with the inline style, you basically get the same benefit as the $inject property. And so these are the kind of things you have to keep in mind when doing minification. The other thing is we've already compiled Angular min.js with all the right settings and all the right performance optimizations that we could tweak into it. And so don't compile it again because chances are that you're not going to get all the right settings and you're going to break things. Instead, just include it as dependency. And if you insist on having a single JavaScript file, you can simply concatenate the Angular min.js either before or after your existing code base as part of the compilation process where things get minified. Take some time, make sure this sinks in. So the big thing about Angular is that we embrace HTML, JavaScript, CSS, and all the technologies that are there. But most of these technologies are for static documents. And so what we want to do is we want to extend the vocabulary of these technologies for dynamic documents. And so the point is, don't fight the HTML. Don't pretend that the HTML is not there and abstract it away into layers of some other stuff. Instead, embrace it. And what we do with Angular gives you is the ability to augment the HTML vocabulary through the concept of directives. So if you really miss your blink tag and you want it back, Angular can give it back to you. Right? You just create a directive saying if you come across a blink tag, then do all this stuff to implement it. In other words, think of HTML as a bit of a DSL, domain-specific language, right? That you can, if you really wish you had a tab or a pane or a zippy or some special, hover directive, hover behavior attribute, and browser would behave this particular way, you can have it with HTML. This kind of takes a fundamental shift in the way you look at how to build applications. But there are limitations to what you can do with declaring this component. So first of all, one way to declare a component is as a component as an element name. This is what's shown right here. In other words, you can make a new thing like a tab or a pane or a zippy. Now, we recommend you place a prefix in front of it. We'll talk about it in a second or later. But you have other ways of declaring it as well. So you can use it as an attribute. It doesn't have to be an element name. And this gives you choices. We're not saying one is better than the other. We're just saying there's different ways of doing it. And finally, you can also use it as part of a class. Now, this could be a bit of surprising that all of a sudden, by adding a class to something, you can actually trigger behavior. But Angular allows it to do this as well. And finally, there are certain things that are not allowed in HTML, like, for example, putting custom tags or inside of table body. Like, the only thing that you can put inside of table body is a TR, table row. And so for that purposes, we have actually a comment, because comment can be placed almost anywhere. So you can use the comment to instantiate your components or your directives. And so you have these choices, and it's up to you to decide which of these choices are your preferred way of expressing yourself. But there's always but. There's IE, and IE has few quirks that you need to be aware of. So before we get to IE, I want to point out that we strongly recommend of putting a prefix in front of it. It's like my component. Now, clearly not the prefix mine, or clearly not the prefix ng that we have seen people use it as well. That's our prefix. But the prefix can be either as a dash or a colon. So if you wanted to use as an XML namespace, and if you like that, you can do it as a colon. But if you just say, forget the namespace, you can use it as a dash as well. So in IE, this always works, basically putting it as an attribute. But if you want to use it as an element, there's a couple of surprises in IE. So suppose you have an HTML like this, which basically says HTML body, my tag, some text. What you would expect that rendering, when this is IE8 specifically and below, is you would expect you have an HTML document for the HTML, then you have a body, which is a child of HTML, and then you have my tag, which is a child of body, and my tag has a text element, which has this text, some text. Right? This is the expected DOM tree. What you actually get out of IE is you get HTML body, my tag. Notice that the text isn't a child of my tag, instead it's a sibling. Basically, IE treats my tag as a self-closing element, just like a BR. BR cannot have a children, or HR. There's no children allowed for it, and there's no need even to put a trailing slash on a BR because there's no other way of declaring it. And this is how IE treats unknown tags by default. And notice it also creates this, it treats the trailing or the ending tag as a self-closing tag by actually taking it and inserting it with the invalid character slash in there. But there is a way around it. So it turns out that if you just say document create element and specify a custom name, then IE says, okay, now it's a real thing. I will behave the way you were supposed to. So you have two choices. You can either declare a namespace and then use the namespace and then fixes it, or you can do what we're basically showing here, that if saying if you are IE less than 8, please execute these things. Now, that means that you cannot place these things inside of at the bottom of the page, because IE needs to execute the script tags before it sees the custom elements. It also means you cannot do it asynchronously. So this has to be at the top. So that kind of things to remember. Also, IE does not have certain things like JSON out of the box, and so we expect that for IE you get a polyfill to bring it up to modern standards. So you get polyfill for a JSON and also polyfill for some APIs like string to trim, etc. So finally, some people feel very strongly that if I add a new element like my component or a new attribute, that actually doesn't run through the HTML validators. And for those of you who feel strongly like that, we give you the option of prefixing everything with either X or data. And that should make the validators happy. So the X and data prefix are essentially ignored and stripped away, and then you have a choice of using either a dash or a colon for your namespaces, and that hopefully should give you plenty of freedom to decide which way you want to set up your templates. So in Angular, a lot of design was driven by separating the presentation and business logic. We wanted to make sure that by separating the two pieces out, you get a lot of benefits. One is testing, because if you have them mixed together, it's very difficult to write a test that automatically requires a special DOM to be present. The other thing is that by separating the presentation and business logic, when you look at a controller, you understand the behavior of the application, because all of this stuff about how do I render it is subtracted away from it. It's just purely just what the application does. And so that's a great benefit that Angular brings to the table, and a lot of design decisions, namely how we structured the scope and the view and the dependency injection, were specifically done so that you can have this clean separation. So please, don't undo our work by putting DOM back into the controllers. So controllers and services, when should you use which? So first of all, controllers, as I said earlier, should not refer to DOM. If you really need to do DOM manipulation, that's what directives are for. We'll talk about them separately. And controllers really should have the behavior for the view. In other words, what should happen if I click X? Or where do I fetch the data so that the view can be rendered? Those are the kind of questions that the controller is interested in. Services, on the other hand, are interested with how do I do X? So let me give you an example. Let's say you have an email application and you wanted to mark a particular message as read. Presumably, the marking of the message read can be done in a lot of different ways in your application and from a lot of different locations. And so the behavior of how do I mark a message read should be placed inside of a service. But the glue logic that glues the view to a particular service, and then the logic that also fetches the right email messages to be rendered for the view, that should be placed inside of the controller. There's other differences between controllers and services, namely that controllers, you get a new instance per view. So every time you navigate to a view, you have a new instance. Whereas services are singletons. So they're for the duration of the application lifetime, which means that things that need to be cached and not destroyed between view navigations are perfect places for services. The other thing you want to keep in mind is that oftentimes people on a mailing list ask, I have one controller and I need to call some method in another controller. How do I get a reference to another controller? Well, that's a dead giveaway that your logic should be inside of a service, not inside of a controller, because the controller is really meant to just hook things up together. And so if you need to have something that's actually needs to be done from two different locations, service is your friend. Now, as I said, services should not refer to DOM either, with a little caveat. And the caveat is that sometimes you, for example, need a service like a dialog box that is responsible for pulling a dialog template in and rendering it. And a dialog box really needs to be placed, it needs to place a div inside of your body of the application. So it's not like a directive that you have to place somewhere. It's just something that needs to happen in order to get the job done. And in that case, very limited amount of DOM references might be acceptable inside of your service. Keep in mind that every DOM reference you create could be a source of a potential headache from a testing point of view. So another thing to kind of keep in mind when dealing with scopes is that scope is the glue between the controller and the view, right? The view is what the template turns into once it gets executed. And a controller is what is responsible for collecting all the data. So from the point of view of a controller, scope should be write only. In other words, the controller's job is to collect the data that needs to be rendered, place it in a scope, and be done. From the point of view of the view, the scope is read-only. That is, I'm only supposed to be reading properties out, not writing properties back into the scope. And this, we'll talk about more about the ng model and how that's important. People oftentimes think that the scope is the model, and that's not the case. Scope has references to the model. So you create your own model object, and then you put a reference to the model object from the scope. So in the view, you say model dot whatever property in the model you want to access. Similarly, if you have a form, you should have a form model, and then the scope basically says model dot property X, and then the scope, the view is updating a property on a model, not a property on a scope. So as I said earlier, right, the purpose of the scope is to refer to a model, not to be a model, and this is important because your model should be your own set of classes and objects that you create. Unlike most other frameworks, we don't force you to inherit from any particular object or any particular class or any particular structure or special getters or setter methods for your model. So you really should be free to declare any or reuse any existing object as your model for that purposes. Now, there's this tricky part about the bidirectional data binding, and I say tricky because whenever you have ng model, sooner or later somebody basically files a bug like this with us. And we get plenty of this. And let me actually demonstrate what this bug does. And yes, thank you. So here is inputs, two inputs over here, as you can see. And one is inside of a switch statement, and one inside of it's outside of the switch statement. The fact that it's inside or switch is irrelevant. What matters is the switch statement creates a new scope. So here's an interesting behavior. When I start typing here, the other form changes, but the moment I start typing here, they become disconnected, and typing at the second one no longer changes the other one. People, there's got to be a bug filed every month about this particular thing. I know it's unexpected and it's strange behavior, but if you think about it, it actually makes sense. What's happening is you're saying that you are binding to a property called the field, and this is binding directly on a model. This is where we were saying you should be using scope purely as a read, not as a write. And so the strange behavior becomes because the parent scope has the field, which was over here, and when I type it, the child scope gets the property inherited. This is how prototypical inheritance works in JavaScript. But once you write to your child scope, you're overwriting the parent. The parent property no longer becomes visible, and you essentially become disconnected from it. And so the good rule of thumb is, whenever you have ng model, there's got to be a dot in there somewhere. If you don't have a dot, you're doing it wrong. So the way Angular does watching of model is through basically a very fancy way of dirty checking. And in order to enable dirty checking, there is this function called watch. Have you guys come across that, used it? Okay. And watch has two functions that it takes. It takes what we call a getter function and then a reaction function. A getter function is something that we call all the time to figure out if a particular property has changed. That means, because we call it all the time, it has to have a couple of properties. First of all, it has got to be very fast. So don't do anything crazy inside of the watch function, because it's a sure way to make your application slow. The other thing is it should have no side effects. So, there shouldn't be a counter or anything going on, because we're not guaranteeing how many times we call that function. And finally, it needs to be idempotent, which means every time I call it, I should return the same value the number of times I call this function should not depend in any way that the value we get out of it. And so those are the kind of things to keep in mind when writing a watch function. So let's talk about modules. As I said, modules are a way of configuring the injector. And we allow you to have multiple modules and then have modules depending on each other. The primary reason to having multiple modules is to have third-party libraries to provide something, and then your application then depend on the third-party library through the module system. So like Angular UI by Dean. Where's Dean? Somewhere over there. Hi, Dean. Then Angular UI project will provide a module that you simply include in your application, and then you have a dependency on it. Now, people just take the module idea and they kind of run with it and then go crazy, and they create a module. They take their application and they chop it up into different modules, and they'll have a module for all the controllers, and module for all the directives, and module for all the services. And while that may look like a good idea, it's actually self-defeating, because the purpose of a module is to be able to instantiate a portion of the application. And if you chop it up by type, it's very unlikely that you can instantiate just the controller without any kind of services or any kind of directives. Usually things come in clusters, right? So a particular component, particular controller needs a particular set of services to get its job done. And for rendering purposes, we also need a particular set of directives. And so a better way of structuring the application, if you wanted to take advantage of this, is by feature or by things that go together, rather than by type or the kind of things that you have. Now today, there's very little benefit to actually splitting up your application into these chunks, because all the module contains is configuration information. And while the benefit of splitting up the application is minimal, there is a benefit to having different modules for your tests. So, if you have a scenario for the test where you want to replace the backend with the fake backend, then you should have a module for that which resets all the components in a particular way. If you have another kind of test which tries to do it on a much higher level, where the services are mocked out rather than the actual communication with the server, then maybe have another module for testing purposes only that does this. So you could use module as a way of grouping related configurations for your tests together. But there's another reason to break up the modules. And while today it's very difficult to do lazy loading of your application, in other words, lazy loading of portion of the application and the views, hopefully in the near future we are working on enabling so that you can lazy load the JavaScript code along with everything else. And what that's going to mean is that your application should be broken up by modules by view. So each view should have a separate module. And the reason it's by view is because those are all the things that are related to each other, and those are all the things that we'll need to bring it together. And the view is what we're going to be able to then lazy load partially in the future. So if you really insist on chopping things up, by view is a good way to go rather than by type. Okay. This should go without saying, but it's surprising how many times people send us bug reports with stack traces and it's minified stack frames on there. And the trouble with minified is that, hey, it's fine for computers, not so good for humans, right? The line numbers are off, the function names are mangled. I mean, there's nothing to be gotten from a stack trace like that. And so spend the time to set up your environment so that you can run it in production with non-minified version, and in the development world with in production with minified version, and in your development world in a non-minified version, and it should be easy to switch back and forth and enable them. The benefits of minification we already mentioned is, it's a smaller code base to send across. The inside of development, you really want to see a full stack trace to figure out what's going on in there, with line numbers and everything else. So finally, let's talk about a little bit about deployment techniques. So as we said, you want to minify and concatenate your JavaScript code. Although the concatenation it used to be a clear yes, you need to concatenate in order to have a performance impact. It turns out with modern browsers, you should read some of the latest findings and blog posts people have and experiments they've done. It turns out that modern browsers are pretty good about loading things in parallel, executing them, and so it's not exactly clear that concatenating everything into a large one script tag will gain you all the benefits. But do your own tests, measure your own way. Don't take my word for it. Every app is different. Second, enable gzip. It's a very simple thing to do, and all of a sudden your download is almost twice as fast. Again, a lot of server people forget to do that. we think that index.html should be non-cacheable in the browser, so that every time you go to a particular application, you get a brand new copy of index.html. The reason for that is that you want to be able to easily change the version number of the libraries that is defined inside of the index.html. But the libraries themselves should have a version number encoded in the URL, and those should be strongly cached. So you basically tell the browser, go all out on these particular items. Because if you wanted to upgrade in a particular version, then you can just change the version in index.html, and everything else is going to automatically load the proper versions for it. And I think I finished 5 minutes early, so I would love to have some questions. And I think there's good t-shirts to be gotten for good questions.
And I have
don't forget, we're streaming, so be careful what you say. But do get also a mic before you say anything.
So I have the mic over here, and I'm going to ask you to also speak up so that everybody in the room can also hear your question. So question over here.
Hi. We're about to deploy to production our app rewritten with Angular. My question is it possible to precompile the HTML? Because when we do ng include, it's going to be a string, right?
Mm-hmm.
Is it possible to somehow do a compile on the back end, so when we get to the browser, it's already in JavaScript?
So your question is, can you precompile the templates on a server?
Correct.
Not as of yet. That's a very complicated thing that you're asking, and we're thinking about this problem, but we don't think that ever is going to be a seamless solution. If we do allow you to do this in the future, it's going to be it's not going to be a trivial setup because of the nature of this particular problem.
Okay.
But it turns out that the compilation does not take that much time. So you get a lot more benefits by concatenating things together. So for example, in the case of an Angular application, if you have lots of small views and lots of small directives that have their own files, you can benefit greatly by having the browser make a single request rather than lots of small ones. And the way you can do that is Angular has a template cache service, and you can auto-generate a module where you read the HTML file into a string, and then you just put it as a template cache.put in your URL and the content. And then your application still looks like it's fetching from the server, but actually everything's pre-cached in the browser in a single shot. So it's a bit of a work you have to do on your side to generate this module, but once you do, then you get great benefits in terms of performance.
Are you saying you serve the index.html along with the templates that will be in the ng include?
I'm saying that take all the stuff that's related to a particular view, put it in a single module, and things that are HTMLs, they can be pre-cached by executing a piece of JavaScript that basically says template cache.put the URL where this HTML would have been and the content of the HTML.
I see. All right. Thank you.
Question from this side of the room.
So I have a question about lazy loading, and you were talking about like the JavaScript and the HTML loading. So we're using right now ng include. I just have we have two different approaches, and I want to see like what's the best practice. So one of the ways how we can do it, we can completely preload. Like let's say I'm abstracting the view like div and ng controller, and I put all the logic for the controller and the HTML logic on this template on a server. And then I'm calling ng include based on demand, and I'm loading HTML, I'm loading ng controller, and I'm loading controller together with it. And it actually seems to be working, everything like executing totally fine. There is no binding delays or anything. Another strategy that we actually have on the team, and I'm kind of deviating a bit. What if we will have a div with ng controller, and inside of this div, we're going to load JavaScript for the controller as a part of our bundle. And inside of this div, we're going to have ng include. And then controller is going to, on demand, is going to decide when we want to load a particular HTML for this. So if there is any better strategies or if there is any best practices for doing this, because like in one way, we kind of unloading a bit of our JavaScript. So our initial bundle is getting smaller. In other way, everything is being bootstrapped right away, and then like those type of things like shared data or like events handling is kind of already there, is taken care of, because controller was there like from the beginning through the whole page cycle. So we kind of like have issues both ways. One is kind of lighter but more complex, another way is less complex but heavier.
So the only thing I can tell you is that you got to measure these things. It's hard to have a overall statement of this is faster versus that one. It's something that you have to have tests for and figure out, okay, and these browsers, this seems to perform better, or those browsers, or just get some numbers to it. It's hard for me to say that this is better than the other one.
Are there like any hoops that we might encounter in one route or another?
The only thing Angular provides, as I said earlier, was this template cache, which allows you to pre-cache URLs with an HTML responses for them, so that you never have to change the way you write your application, but the browser will not incur an HTTP GET for that particular template.
All right. Yep, thank you.
I think you should get Dean. He looks very excited over there. Make sure you talk to microphone.
Hoping you can hear me, but I don't want to be too loud. On one of your slides, I thought it might even be relevant to go back to it, the switch with the input. You said you'll break if you read from an input and you, in a child scope, like inside the switch, if you mess with the value, you'll break the relationship to the parent. But you never explained how to fix it. And one of the things I do is I do $parent dot the model name. And I also do $root, but that was it.
So you could refer to the parent through $parent. That's not recommended. Like, we don't think that's a good practice. Instead, the answer is, I actually did mention it in the slides, is that your ng model should have a dot in it. If it has a dot, that means that the property is not on a model, but a property is on a model. And if it has a dot, the property is not on the scope. Instead, scope simply has a reference to the model, and the property is on the model. And this particular way, the whole thing gets fixed. So while $parent is a way of working around this particular issue, it's fragile, because if somebody introduces another scope above you, then you have to do $parent. Whereas by having a model separate, it always works, no matter how many intermediate scopes there are in between.
Me? All right, cool. Hi, my name is Gene, and I'm a software engineer working at Ancestry.com. We've implemented this bunch of services that make Ajax calls, and then I'm curious about what's the best way to get the data back from that service which is not synchronous. So right now, actually, we are broadcasting the result back to the controller, and that controller implements the listener. And then we don't think, well, some of us think that's the best way, but I've seen couple of different patterns, such as returning promise directly, or you maintain reference to a scope variable so that Angular refreshes the data reference for you. So which way would you recommend? I'm curious.
I think promises are the preferred way in Angular, and I think this is where more of our APS is going to be moving towards. The reason why we like promises is because it can synchronously return to you an object that you can keep reference to, instead of you passing in like the object where eventually something is going to be placed on, or doing a callback function. And then the rest of the Angular system already knows about promises. And when promises get resolved, it automatically calls apply for you, and they are getting resolved at the right point in the life cycle of the application. And so all of these things kind of, I think, are pushing you in the direction of promises. I think the promise is the proper way of dealing with this.
We're going to send it back to the other side of the room. Who has a question on this side of the room?
I have a question regarding performance. So one of the things I noticed was that we were running into some performance issues with Angular, just from if you had lots of rows in something, because it's an update, lots of models, run lots of filters, and so on. But my question is slightly different. I want to know, like, what happens if you have lots of different views, like, for example, you have tabs in your app, like your app is very deep and people move around it for a long time. So a lot of stuff gets instantiated, and then you update something on your root scope because it's used in lots of different places. The single source of truth, right? You want it to be in one place. Are we going to see just performance issues from that, or can I like and how to solve that basically?
Okay, so performance in Angular is directly dictated by two factors. One is how many bindings you have on a page, and a second one is how expensive the getter functions are. So as I said, the getter functions need to be really, really fast. So be careful that if you are calling $watch not to insert a slow function in there because it can very quickly multiply. As far as number of bindings on a page, it doesn't matter how big your application actually is. The only thing that matters is what's currently rendered. So things like ng-include or ng-view, they break that portion of the application away, and it's no longer part of the redraw cycle. But things like ng-show and ng-hide do not break. So don't think that by hiding something using ng-show or ng-hide, you're actually losing these particular things. The other thing is if you have something like a repeater, you shouldn't have more than, I don't know, like say 100 rows, because that's just the limitation of what a good UI is. Like I don't want to see 1,000 rows presented to me, because as a human being, like I can't parse this particular thing. It really is calling for pagination or some kind of searches, etc. When you're using filters, sometimes filters can be expensive, especially when running them over and over again. And the solution to that is actually to have an intermediary model. Rather than running the filter inline in like ng-repeat, item in items, filter, whatever, have a watch on the filter property, and then whenever the property changes, then refilter it and copy the values into a secondary model, which then you use for ng-repeat. So those are different strategies for dealing with it.
Very good tips, thanks.
Hi, so we're actually implementing Angular on the front end in a pre-existing Rails app, and one of the things we've come across is that sometimes when we return ERB partials with ng attributes spliced into them, because like I said, we're splicing Angular into existing apps, right, rather than rewriting everything, the ng attributes come back dead. They just don't do anything. So the question is fairly simple. Can you maybe enlighten me as to why?
So I'm guessing that the way you're putting these things in is you're using probably like inner HTML or something.
Yep.
Okay. Angular needs to know when the DOM changes, and specifically Angular kind of wants to be in charge of the DOM changing. So what's happening is Angular thinks it's in charge, and then you're kind of going backdoor and putting in inner HTML. You can still do that, but you have to run it through you have to notify Angular. So the way you do that is there's a compile service that you use to compile this particular thing and run it. But we've kind of already done all these things for you. So I think the answer is that you should be using ng-include rather than inner HTML for inserting these particular things in, because ng-include does a proper compilation and does a proper insertion and the whole life cycle and the whole scope management for you. I think back to the previous question, you were asking about all these things getting instantiated. The other thing that scopes do is they worry about memory management so that you don't have memory leaks. So I would say is that you need to load your partials through ng-include rather than inner HTML them. Now, eventually, browsers might implement a DOM mutation events. And if they do, then simple act of doing inner HTML would fire events that the Angular could eventually listen on and do this. But as of today, browsers don't do this, and those that do, those APIs are deprecated. But there's some work on new APIs that will actually enable this, but that's not something that's available in browsers today.
Hi, over here.
Okay, I think that's the last question. No, we have people from the internet. Oh, okay. Go ahead.
So my question is about the events API that's on the scope. I've gotten a lot of mileage out of using it as a sort of an application event bus that allows me to have my components communicate with each other. But I haven't seen a lot of documentation or best practices about how one should go about doing that, or even if it's a good idea. An example of the problem that I run into is that because it's sort of a directional hierarchical bus, you have to emit up and then rebroadcast down if you're at a kind of a leaf node. If you've got a leaf component and you want to catch that event
siblings to
somewhere
talk to each other.
Or, yeah, if you want siblings to talk to each other, you have to go up and then come back down. So you end up kind of playing this game, renaming your events, because if you catch the same event you throw from the root, it ends up with a
Well, you can just get a reference to the root node and fire an event on the root if you want to broadcast it to everybody.
I suppose that's true. I always feel like the root is grabbing global state, so that feels a little dangerous to me. But
it's not exactly global state. But anyways, finish your question.
So the question was, I was thinking maybe you could, well, maybe you've kind of answered it, but I was wondering if there are some best practices when dealing with the events, or what were the design goals you had in mind when?
Right. So events, what they do is they provide a communication channel between two parties that don't want to be too close to each other, right? They don't want to have references to each other. And that has advantages and disadvantages. The advantages is, hey, you know, I don't have to care whether you exist on the other side. I simply fire off all these events. And if somebody listens, great. If nobody listens, that's fine too. But it also makes a very fragile API, because if you change the name, or if you fire before somebody registers, you know, there's all these corner cases. And this is true for generally about events, not just for Angular. So while certain things are well solved using events, for example, you know, location changes, and we can broadcast location change, and then you can veto location change in the controller to prevent you from navigating somewhere else. In general, I think for apps, the events are less useful, and especially because Angular has data binding, so you don't need to do many things. What events are used for is data binding, and we already done that for you, so you don't have to use that for it. So the question of whether or not to use events really should be a question of how tightly coupled do you want two components to be, right? If you really want them to be at a distance, then events might be the answer. But most of the times, I think injecting services and doing direct communication is probably preferred and more robust way of dealing with these things. But you know, it depends on your case.
Hey, Mishko, I've got a question from the internet. And I
Yes,
believe
please
this is-
channel the internet.
Yes, this is from Dave, who I believe is the guy who made those beautiful Angular stockings for Christmas.
Yes, yes.
So we should definitely
oh my
answer
God,
this
I
question.
was so, you know, I was jumping when I saw it
If
yesterday.
you guys haven't seen this, check out our Google Plus stream. His question is, apologies, Dave, if I've gotten you the wrong Dave, but hey, what's on tap for Angular 2.0?
Oh, wow. That's a loaded question. So we are working on kind of the future of where we would like to take Angular 2, and there's a couple of things we would like to attack. First of all, we want to be able to do lazy loading of JavaScript. That's through modules that we've described. In order to do this, we need to have a hierarchical injector. Right now, injector is only one. We don't have concept of hierarchies. There's a lot of different things that come with that. We can get into it later. The other thing we want to be able to do is server-side pre-rendering. Somebody asked about that earlier. It's a very complicated question, but the idea is that if you're somebody like a search engine and you want to see the actual HTML, also, in order to render the application very, very fast, it'd be nice if the server could pre-render the original page, and then Angular could just somehow be able to attach to rendered state. Now, it sounds easy, but in reality, it's quite complicated, because things like repeaters could not be present because they could be repeating over 0 items, and blocks could be hidden, and so on. And so it's an interesting problem space. And also, we'd like to fix the directives API to simplify it. There's a lot of people that ask questions about, you know, the linking and the compile function. So we figured out a way to get rid of the compile function, just have a linking function, and actually turn all the directives into just plain old controllers that you're already familiar with. So there's a lot of things like that coming in. What else am I forgetting? Brad?
Okay, so there's a lot of stuff. We're going to have a blog post soon.
Animation
Yeah, animation.
is the big thing that we wanted to be able to do, so that you could, if you have a repeater and you want to animate items coming in and out, you should be able to just say, you know, animate X, or animate using, you know, foo animation. And it should be able to just provide this and in and out, because right now animation is quite complicated.
Great.
That's
Okay,
the
so
big thing.
thank you, Mishko. We'll close it off. And for folks who have asked questions on the internet, we will get to those questions, even though we didn't answer them here.
Okay.
So I guess at this point we say, I feel like the friendly giant, which will amuse James, who knows what I'm talking about. But farewell to our friends on YouTube. Thank you for joining us. And for those of you who are here in the room, please stick around. We have a couple of just notes and comments for you, and we'll be around to answer your questions as well. So
Shirts?
shirts, yeah, we